Okay, good morning, students. One second. Yeah, good morning, students. So happy to meet you all today morning. Let me share my presentation. Okay. So in today's class, we are going to discuss about a very important concept, that is statistical inference. Okay. So what is that statistical inference? Why we have to discuss that statistical inference is it's a very important concept in data science. Whenever you are dealing with a very huge data set, okay, we could see that nowadays the data set was really huge. Okay, so the sources generates data very rapidly. Even you take us, okay, a human being, the number of files that we store in our laptop, the number of files that we store in our mobile phone, it is exponentially increasing. Okay, so as we are all on our online mode, okay, we are all in online mode, and you imagine the total number of files that you save per day in your laptop, okay, or the total number of files that you save per day in your mobile phone, the total number of data that you generate per day. Okay, so that was really huge. Okay, and now when such data is or your thoughts on social media, you think about people before some 5 years, they were reporting or recording their views. But now, as social media is emerging, people started recording their views in almost every social platform that they have. Okay, so they just post their photos on Facebook, Instagram, and they put their views on Twitter, and in every social media, people started recording their views. All right, so the amount of data that is generated is very huge. Now, how are you going to analyze that huge amount of data? It was very vast. So such a large data set, how do you analyze? For example, I'm asking, what is the average height of a person? Okay, people living in India. Okay, so I'm asking, what is the average height of people living in India? So it is people living in India is greater than 130 million. Okay, we are 130 or 140 million. So how do we just take all 140 million people's height, then take an average? It's really a tedious job. Okay, I hope you can understand what I'm coming to say, right? So when dealing with such a very big data set, how do a data analyst work? Okay, or how do a data scientist deal with that is by the method of statistical inference. Okay, they do just a statistical inference. So what is statistical inference? I'll tell you with a very good example. Suppose your mom is cooking a very delicious biryani. Okay, want somebody to taste it. Okay, and she's calling you, hey, come on, please come here and just come and taste this biryani. So what you will do, you will just go to the kitchen and take the bowl of biryani and you will pour it in your mouth. You won't do that, right? So what you will do is you will just won't be a cravey eater like this. Okay, once your mom serve biryani, you will do that. But if your mom want to taste the biryani, you will not do this. Okay, what you will do is you will just prefer a plate. Okay, you will take a small plate, keep a little bit amount of biryani, and then you will eat. All right, so that little bit of biryani that you taste will tell the flavor of the whole biryani in the pot. So now that is what is statistical inference also. Okay, you take a little bit of data. There is a huge amount of data, but from the huge amount of data, you take a little bit of data and you just analyze the data. So by analyzing a little bit of data, we are going to say about all the data. So that is what is the statistical inferences. Okay, so let's read the definition. Statistical inference is the process through which inference about a population are made based on certain statistics calculated from a sample of data drawn from that population. Okay, so by analyzing a sample of data, we are going to tell about this is how the entire data is going to be. All right, so that is about, for example, one more example I'll tell you. Suppose your mom is checking whether the rice is cooked. Okay, she will not take every single rice and she will check out. Okay, she will just take a little bit in the spoon and she will check it and say, yeah, the rice is cooked. Okay, so this is what is a statistical inference is. Instead of analyzing a very big data set, what you will do is you will just take a little bit of a data set and you are analyzing it. Now the question is, what little bit? Okay, how much little bit? So how many times I should check? Okay, so that is what we are going to do in today's class. So there are two approaches with which people just analyze it. Okay, whenever statistical inference, there are two approaches. One is the frequentist approach and the other one is the Bayesian approach. Okay, we'll see with an example what is that frequentist and Bayesian approaches. Okay, suppose you approach a doctor, all right? So, and you say, doctor, I have a very severe stomach pain and please just analyze what would be the problem. Okay. Now the doctor will be asking you a series of questions. So he will ask, did you take something junk? Okay. And then what about, is your pain is in the lower abdomen or in the upper abdomen or in the side or left side or right side? You please lie down and let me examine. So he'll be examining by asking you quite few questions. Okay, so as he just examine, he'll ask you, okay, is the pain is here in this part? Is the pain is here in this part? So now he just define, he will probe you by some questions. Okay, he'll probe you with some questions. And after he probed with the question, he will say, yes, I have severe pain only in my right side of my abdomen. Then he will conclude, okay, right side, which all the organs. So there may be a little bit of, you have taken a junk food and maybe a food poison. Okay, it may be a little bit of food poison. So frequentist approaches, the doctor with his knowledge, all right, with his knowledge, he analyzes, or a data scientist with his knowledge, he analyzes the data. Okay, that is what is called as frequentist approach. Okay, you ask again and again a lot of questions and then you analyze it. Then what is Bayesian? The word Bayesian itself say probability. Okay, so and also the doctor just you go and lie down on the bed and you say, sir, doctor, I have a severe stomach pain. The doctor analyze. Again, the same frequentist approach is used. Okay, so he just asks you whether you had a junk food, which part of your stomach you have the pain, and then the doctor also analyzes your history. What is that he analyzes? He say, okay, the previous month also you had a food poison. The 1 month before also you had a food poison. That is, every month you are having a food poison. It means that there is some problem with your stomach. So let me just probably this can be the problem. Okay, so he assumes and say probably. So what is the difference between frequentist and Bayesian approach? Frequentist approach, again and again the samples are tested. Okay, and the data scientist with his knowledge, he comes to a conclusion. But in the Bayesian approach, again and again the samples are tested. In addition to that, the history is also, it's okay, if this sample is analyzed before, what will be the output? That output is also taken, and then probability also come into picture. So all these, drawing all these, a conclusion is drawn. Okay, so these are the two approaches used in your statistical inference. Okay, now what can be a different type of estimation? Okay, what are the different type of estimation is? There are three types of estimation. Point estimate. What is point estimate? Okay, so the average height of every Indian is maybe 153 centimeter. Okay, so or 147 centimeter. The average height of every Indian is 140. So I just arrive at a point. I estimate and I say a point, one single point. The average height of an Indian is 150 centimeter. So what is the confidence interval? So having the point estimate at the middle, listen very carefully, having the point estimate in the middle, I say the average height of an Indian may be 148 centimeter to 152 centimeter. I just have two-sided interval or two-sided range for that estimation. That is what you call as a confidence interval. Okay, So first is point estimate. What is point estimate? You just click and say, this is the point. Okay. So confidence interval is there will be a lower limit and there will be upper limit. So I say, and for the lower limit and the upper limit, you will have the center as the point estimate. Okay. You say that this is a point estimate. From the point estimate, so -2 and +2. Okay. So he can be a -148 centimeter to +152 centimeters. So this could be the average height. Then the third method is what you called as a hypothesis testing. So hypothesis testing we will be discussing in detail in the coming classes. Okay. So far what we have discussed is we discussed what is statistical inference. Then we discuss what are the two approaches for statistical inference. Then we discuss what are the classes of estimation. So one by one we will discuss about the estimation techniques. Okay, so number one is the point estimation. Yeah. Number one is the point estimation. What is that point estimation? So I want to calculate the average height of Indian. Okay, I want to calculate the average height of Indian. For that, what do? I just calculate the sample mean. Okay, sample average. So how do I arrive at the sample? There are different techniques. We will be discussing that. So you take initially there are 130 million records available. So taking out the height of all 130 million records divided by 130 million is really a very hectic job. Okay, so what do is first I draw 10,000 samples. Then I calculate the sample mean. Then again I draw 10,000 samples. I calculate the sample mean. Then again so I repeat the test for 200 times. Okay, I draw 10,000 samples and I get 200 times. And then I take the average of all the 200. Okay, so that is what, so you imagine this is a total record available. All right, so all these total record I cannot really, it is very hectic for me to analyze. So what do is I take the first 10,000 samples. Okay, I calculate the mean. Then actually the sample mean we call it as X bar. All right, we call it as X bar. Then I take a small sample and I calculate this is X1 bar, this is X2 bar. So again I take a little bit of sample and I do X3 bar. Okay, so I just assume that the population mean should be, the population average should be X1 bar plus X2 bar plus X3 bar divided by 3. Okay, so this is what is the point estimate. We just estimate the sample mean. All right, so for that we have a technique called okay, here is what is the point estimate is. I'll come to this program later, a little bit later. Right, how can we do that sampling? Okay, I told you we are picking up from a very huge sample, we are picking up, right? So how do we do that? For that, the first technique is sampling distribution of sample mean. The first technique that we use is sample distribution of sample mean. All right. So how do we do that? I told you a very big data set is available. All right. So from the data set, take a little bit. Okay. So calculate X bar. Then take one more little bit. Calculate X1, X2 bar. Then again you take a little bit. So likewise, you repeat the test for so much time. All right. So maybe it's 130 billion records. So you have to at least repeat the experiment for 10,000 times. All right. Then what you do is the population mean is nothing but X1 bar plus X2 bar plus X3 bar divided by 3. You understand? So here I perform the experiment for 1, 2, 3, 4, 5. So plus X4 plus X5 divided by 5. You understand? So that is what you called as sampling distribution of the sample mean. The first technique. You pick up few samples, then you just arrive at the mean. At the last, you just perform the average of all the mean. Okay. So that is what. Okay. A very important point is I want everybody to remember this formula, standard error. Okay, so what will be the standard error for the total number of samples that we do here? Okay, the population mean is mu and the average mean is X bar. So what will be the error? So the deviation is calculated using the standard error deviation is calculated using this formula. Please have a look at this formula. Now, The second technique, yeah, here we have done a little bit of, now I'll come to the program. Okay. Yeah. See here, we are generating a data set. Okay, so using Poisson distribution, we discussed the different type of distributions in the previous class, right? So this is a syntax for Poisson distribution. Using Poisson distribution, I generate data set 1 and also I generate data set 2. All right. So together we merge it as data set. Okay, together we merge it as data set. So what is the size of the data set? It is around 2,50,000 samples. Okay, 2,50,000 samples are here in the data set. Okay, that the age. Okay, they say that it is age. All right. Now what do I do is I calculate the mean of 2,50,000 sample. Okay, what does that mean? It is, I'll just screen a little bit. What is the mean of the population? 43. Okay, the mean of the population is 43. Now what do I do is I just take only some 1,000 samples. Okay, so I just take a little bit of 500. It's not 1,000, it is 500 values. Okay, only 500 values, and I calculate the sample mean. Okay, so among the 2,50,000, we took 500 samples and then we are doing a mean. So it is around 42. So you could see that the difference is 0.6. Okay, I just take 500 samples among the 2,50,000 samples. When I calculated the mean, the difference is 0.61. This is how you do a point estimate. You take the sample and you are doing it. Now let us do sampling distribution. Okay, we'll see how the sampling distribution is done. So again, we perform the same process. Okay, we take 500 samples, but now we perform the experiment for 200 times. Okay, we randomly pick 500 samples. Okay, 500 samples. Okay, but this experiment is performed for 200 times. All right. Now, when I do that for 200 times, my error is very less. Can you see here? It is minus 0.084. It was very less. All right. So to a little bit of, compared to us drawing only 500 samples, drawing 500 samples for 200 times resulted in a little bit of less error. Okay, I could reach approximately 43. There was also the population mean was 43. Here also we were able to achieve 43. Okay, this was a traditional approach. If you could, I'll just share this program in your Google Classroom. You can check it out. This was a very traditional approach, and complexity is also a little bit of less. Okay, because if you take this as a very big chunk, you take this much, then you take this, then you take this, then you take this. Likewise, you take for 200 times and you just do the process. Okay, you just estimate it. This was a traditional approach, and this was also a less complex approach. Okay, now moving on to the next technique, which was a little bit of complex approach. Okay, a little bit of complex approach and non-traditional approach, and also compute intensive approach. Okay, this was a compute intensive approach. Now, what is that? Okay, what is bootstrapping technique? Is you have a very big population. So from that, you just take a sample. Okay, you just take a sample. For example, I have 2,50,000 samples. Okay, from that, I just take 1,50,000 samples initially. All right. So from the 1,50,000 samples, you resample. Okay, the word resample is used. All right, a little bit of one more step. Okay, you resample and you are getting this. Okay, so from the 1,50,000 samples, you take this. Okay, then you take this. Then you just take this samples. Again, you take this samples. Here again, you take the samples. Could you just tell me a difference between traditional approach and this bootstrapping method? Somebody, could you just tell me? This was the traditional approach. Okay, you take here, you just take a little bit of samples and you were calculating. But now This was the bootstrapping technique. Okay, you draw this, and from here you got a little bit of sample, you resample. Can you tell me somebody who understood this concept? Please unmute your mic and you can give the answers. Then I should ask you by register number, by your register number. Okay, shall I call you by register number? Sai Kumar, 53, Sai Kumar is here.
Yes,
I think, yeah, Sai Kumar, can you tell me what will be the difference?
Yes, ma'am. Like in boost, in normal traditional approach, from a big population, we'll be taking several small samples and we'll be working on inferential statistics, ma'am. Whereas in case of a bootstrap distribution, we'll take one sample and within that sample, we'll bootstrap all the data together and perform analysis, ma'am.
We resample
We resample the already taken sample data and perform statistics.
Okay, yeah. So we resampling. That was difference number 1. So Manoj 266, Manoj, can you tell me any other difference you find here? This was sampling distribution of sample mean. This was sampling distribution technique. Okay. So Manoj.
I don't think of any other difference.
You don't think that?
I can't really come up with any other differences.
Oh, you can't come up with any differences. Okay. So Siddharth Reddy 240, can you tell me what is the difference? Can you find out some difference?
No, ma'am.
No.
No, ma'am.
Okay, now I'll tell you one more difference. Okay, resampling is one difference, and the other one is, can you see that we are not replacing or we are not overlapping here? Okay, the samples are not overlapped in the sampling distribution, but here in the bootstrapping technique, we just overlap with replacement. Can you see this? Okay, that's why I draw the diagram like this. Okay, we are just, if again we have taken this and we have completed an experiment, we take a little bit of from that for the next experiment also. Okay, so that was one more difference. Okay, so number 1 difference is you resampling. Number 2 is you just do it with replacement. Okay, that is you overlap the samples. Okay, now we will see what is the difference. Again, here we are performing, this is a code for bootstrapping. Okay, so you perform this experiment. Okay, and now first you resample. Okay, first you resample it, and then again you perform the experiment again and again. Okay, and now you could see that the mean was very less. Okay, initially it was 0.6, then it was 0.08 or something. Okay, minus, and now it was minus 0.001322, very less. And you could see that the mean is more or less similar to that of the population mean. Okay, this was how the point estimate works for 2050 lakhs sample. Likewise, you can work for any number of data set. Okay, so you just work out with any data set. I encourage you to just take out the height value, just take out the marks of a student. You can just take out the age of the people. Okay, so take out any samples, any data set which has samples more than 2,50,000. And now you can run this program and check out what is the real issue. Okay, so I'll also post the samples. Okay, post the data set in the Google Classroom and I'll ask you the questions. Okay, so we'll see by today or tomorrow I'll do that. Okay, that will be your next assignment. All right. Coming to the next one, confidence interval. So point estimate, we saw that using the 2 techniques, the error was very less. All right. But in many times, the point estimate may lead to a little bit of error. So what do I say is, so people say, sharply by 5 p.m. Will you be coming? Sharply by 5 p.m. will you be coming? So I cannot tolerate a little bit of delay. Will you be coming by 5 p.m.? Then you will say, okay, 5 to 5 p.m. Okay, just say 5 to 5 p.m. Okay, please permit me. Okay, even for our class, I just permit students from 9 to 9, 10 or 9, 5. Okay, so we have an interval for any estimation. Okay, so that is what you called as a confidence interval. Okay, now how do you calculate the confidence interval? How do you calculate the confidence interval is have this. Okay, this is a formula to calculate the point interval. Now, always when the confidence interval, your middle point will be the point estimate. Okay, from the point estimate, we'll just say, okay, here the point estimate minus 1.96 of standard error. What is standard error? We saw that standard error formula is sigma divided by root 10. Okay, the standard deviation of that particular samples divided by total number of samples. Okay, total number of samples. All right, so you say that this lower limit will be point estimate minus 1.96 into standard error. And what will be this estimate? Here it says that point estimate plus 1.96 into standard error. Okay, this is what you called as a confidence interval. Okay, now let us say this is the total range, and if suppose I say that 95% of confidence interval, okay, 95% of confidence interval, it means that 95% I'm sure that my output will lie within this range. Okay, I say that this is the 95, for example, this is the 95% of confidence interval. Okay, this was my confidence interval and it was 95%. So what does the mean? It means that 95% I'm sure that the output will be within this range. Okay, so what about 99% of confidence interval? It is a little bit of wider like this. Okay, a little bit of wider, bigger. Okay, so I'm sure that 99% that my output will be within this range. Okay, for example, I'm calculating the average height of Indians and I apply this 99% of confidence interval. So I'm very much sure that it will be within this range. Okay, so it is not exactly 1 point, but it may be around this range. The average height of every Indian may be around this range. Okay, so let's now just do a small quiz from what I taught you so far. Whenever we join a quiz, please join with your register number. Okay.